Assalamualaikum and hello everyone. This video is about our Engineering Mathematics 2 Group Assignment 1. We are from Group 11. Our group consists of 5 members, which is KHAIRUL NAIM, Adam HUSAIRY, EZAIDI, Fauzan, myself, and AMEERA. Okay. Uh, this assignment is about the application of first order differential equation. And this is the question here. An object falls through the air towards Earth, assuming that only air resistance and gravity are acting on the object. Then the velocity v satisfies the equation m dv dt equal to mg minus bv. So from here, we know there is two force, which is air resistance and gravity, that acting on the object. Then where m is the mass, g is the acceleration due to gravity, and b more than 0 is a constant. If m equal to 100 kg, g equal to 9.8 meter per second square, b equal to 5 kg per second, and vo equal to 10 meter per second. Solve for vt. And what is the limiting velocity of the object? So here we need to find vt and the limiting velocity. After discussing with my group members, now we get the answer and understand this question. So to solve this, first we need to know what is limiting velocity. Here is the definition of limiting velocity. Limiting velocity is a steady speed achieved by a freely falling object before it's hitting the ground. Here is the example. This is the object here, the velocity here, and this is the two forces that are acting to the object. The air resistance is pulling upward and the gravity is pulling downward, and here is the ground. So the limiting velocity is the force that achieved by this object before it's hitting this ground. Okay, and this is all the data that we have from the question given. This is the equation, and this is the data, which is we got m here, g, b, and vo. From equation here, we know it is formed using the Newton's second law of motion. This is the basic equation for Newton's second law, which is force equal to mass times acceleration. So the acceleration here, we can replace with dv dt with the changing velocity respect to the time here, v over t. And then the force, we can change it with the two forces that we have, which is air resistance and gravity, which is the mg minus 2 bv. So the form of this equation here, we know it is the linear equation of the first order differential equation. So first we need to convert it to the standard form of linear equation, which is here. So to get here, we need to divide this divide by m. So we got here. This is the standard form of linear equation. Based on the equation that we get, then we need to key in all the data that we have, which is b, we have 5, m 100, and g 9.8. So from here, we can calculate 5 over 100 equal to 1 over 20 equal to 9.8. All right. To solve a linear equation, first we need the integrating factor. This is the integrating factor. To calculate it, we just put the e power of integrate the function of v, which is 1 over 20. So we got the integrating factor is e power of t over 20 here. Okay. Then we insert the integrating factor both sides of our equation. So we got here. So we multiply it, and then we integrate both sides of this equation here. Then we get the answer here. But this one, we still have the integrating factor on this side. We need to know the value of v. So to get rid of this one, we need to divide this equation, divide by the integrating factor, which is e power of t over 20. Yeah. So we got it, the answer here. This is the answer for VT. To find the limiting velocity, this one we need to define the limit of this function as t approaching to infinity. Yeah, this one. So uh, from in this form here, we can see the second term here is going to approach 0 because the denominator here uh, will be increasing without bound, because it will going to infinity. So infinity means there is no limit. So here is will be 0. So this is the answer. We know the limit is 196. Here is the final answer. Limiting velocity of the falling object is 196 meter per second. Alright, that's all from our group. Thank you, everyone.